viewers. Welcome to Elimu TV, a place where you watch and learn. I am teacher Alex Musawa and I'll be taking you through Physics Form 1, lesson number 38. Our title is Measurement of Volume of Liquids. The objectives of this lesson are you must be able to measure the volume of liquids in a container. For example, as you can see from the diagram, we have a tank, and this tank has water, and the water is filled at a height of 30 centimeters. And since the height is 30 centimeters, we can find the volume occupied by the water. We're going to have the height that the water has covered, since it's the space is the volume, it is the volume occupied by the water. So we're going to multiply the height, which is 30 centimeters, by 100 centimeters by 90 centimeters, which is going to give us 270,000 cubic centimeters. This is the volume that is occupied by the water in that tank. We have various apparatus in the laboratory that we use to measure volume. Example is a measuring cylinder. As you can see there is a measuring cylinder, and the purpose of the measuring cylinder is to measure volume of small liquid substances. And we have a pipette. We have a pipette and a burette. Next we have a volumetric flask. What is the work of a volumetric flask? The volumetric flask is used to measure the volume of liquids. It has a meniscus whereby you read exactly is going to give you the volume of the liquid that is going to occupy. We have a beaker. A beaker also is used to measure the volume of liquids at some certain when you pour some water or the liquid that you're measuring, and for this case we have a maximum of 200 milliliters, and that is the volume that the beaker can measure. So, in a laboratory, how do we read the volume of liquids? We read just below the meniscus. At the meniscus, that's where you read. Directly horizontal to the meniscus, that's where you read. You do not read facing upwards or downwards, or you're going to have an error. So you read the meniscus, that the point where the meniscus touches the measurement, that is the part that you read in a laboratory. So how do we measure the volume of irregular objects? Irregular objects, these are objects that do not have a definite shape. So example of regular objects that we have seen cubes, we have seen the sphere, they have definite shape, and we have a formula to calculate their volumes. But in this case, we have an irregular object. An irregular object does not have a definite length, a definite width, radius. So we just use an alternative method, and in this case we are going to use the displacement method. And we have a stone. A stone is an irregular object. It does not have a definite length and a definite width and a definite height. So what we do is we take a stone and we dip into a measuring cylinder that has some water in it. What happens is that the water level is going to rise to a certain amount. In this case, let's say it was 600 ml, and the water level has rose to 800. So the amount of water that has been displaced by the volume of the water that has been displaced by the irregular object becomes the volume of the object. And in this case, the water has come from 600 to 800. So we're going to take 800 cubic centimeters minus 600 cubic centimeters, and that comes to 200 cubic centimeters, and that is the volume of the irregular object. Next, we have an Eureka can, and it can also be used to measure the volume of irregular objects. You take a stone, for example, and tie it on a string, and you fill a Eureka can up to the point whereby the there's the water. And then what happens when you dip the stone in the Eureka can? The water is going to be displaced. Water is going to flow out of the can into the measuring cylinder. So the water displaced is equals to the volume of the irregular object, and that is how we use an Eureka can to measure the volume of an irregular object. And that is the end of our lesson. I have an assignment for you. Number 1, you are required to describe how you measure the volume of a cork using a thread, a measuring cylinder, and water only. Number 2, explain why displacement method is unsuitable for determining the volume of solids. Our reference book is KLB Book 1, 5th edition, 2019 Physics. For more information, contact us on our phone number, YouTube, Elimu TV, on Facebook, Elimu TV, and finally on Twitter at Elimu TV_KE. Thank you for watching Elimu TV. Stay tuned.